Welcome to Be the Programmer, where we learn real-world skills and build real-world projects to help you become the programmer that stands out. Before we get started, the courses in the description below is going to help you take what we've learned here today, practice it by building real-world projects. So be sure to check it out and let's get started. Welcome back, guys. Okay, today we're going to be talking about 10 things about re-renders that separate juniors from seniors. Let's get started. As you all know, we always start with a quick test. Remember to keep your answers in the comment section below and I will be checking them out. Question number 1. If a parent re-renders, do the children always re-render? Question number 2. When you change props, does that directly cause a re-render? Question number 3. When context value changes, who re-renders and who doesn't? Again, keep your answers in the comment section before we continue. Okay, number 1. A component re-renders for exactly 4 reasons. Reason number 1, state change. A set state on this component fires. This is direct and it always causes a re-render unless it bails out. Reason number 2, the parent re-renders. So if the parent re-renders, the component re-renders too, by default, regardless of props. Number 3, context value changes. A consumed context updates. Every consumer in the tree re-renders. Number 4, a used hook update. So a custom hook or library subscription like Tanstack Query, Zotstan, etc. signals and updates to other components. That's it. These are 4 triggers. If you can't explain a re-render, I guarantee you it is one of these 4 that caused it. Okay, reason number 2. Changing props doesn't cause a re-render. So re-renders cascade down the tree. Props are just data carried along. When devs say the props changed and it re-rendered, what actually happened is the parent re-rendered, the child re-rendered. On this render, the prop just happened to be different. The prop change is an effect, not a cause. This is why React.memo exists, to opt out of cascade re-renders. It is also why moving state down the tree fixes performance. The cascade is the default, skipping it is the optimization. Let's take a look at the code on the left. You see, props don't trigger re-renders, the parent re-rendering does. New props only happen if the parent re-renders and produces them. So you can see this component called the parent component. We have a state, which is just n and it's 0. Then we return a child component with a prop name that is equal to static. As you can see, this child component is not using any prop that depends on the state of the parent. But the child will still re-render when the parent does, even if it's not consuming any state from the parent. So even if name doesn't change, you see the child component is still going to re-render. Okay, number 3. Re-render don't mean DOM updates. There are 2 phases. Let's talk about them. So the first phase is when React calls your function. So we build a new virtual tree. This is pure, it's side effect free, and it's cheap most of the time. Then the second phase is the commit phase. This is when React finds the difference between the old and the new tree. So it looks for what changes. Then only nodes that change are updated in the DOM. This is where the effects fire. So a re-render doesn't necessarily touch the DOM. If your component renders 50 times but the output is identical, the DOM doesn't budge. The re-render happened, yes, but the commit did nothing because there was no differences. This is why 100 re-renders per second isn't always a real problem, and why the profiler might show different metrics. Number 4, Setting state to the same value bails out. What does this mean? React compares with object.is. So if the values are the same, there is not going to be any render at all. This is automatic. It's free. There's no memo needed. 2 clicks of set theme to dark, right? So if you click a button to set the theme to dark twice, and the theme is already dark, there's going to be 0 renders. Why? Because there was no change. But for object and arrays, things are different. You need the same reference, not the same shape. So for primitive values like strings, integers, booleans, we get a free bailout. So that means if there's no change in the value, then there's not going to be a change in the render. However, for objects and arrays, we need the reference to be equal. So what does that mean? We're going to take a look at that later. Then reducers, same rule apply via useReducer. We're going to be covering useReducer in another video. Okay, let's take a look at the code on the left. We have a state count. Initially it's 0. So we get a bailout if it's the same primitive. What does that mean? It means if we set count to 0 again, remember count is already 0, we don't get any render at all. However, for this object case, we're going to trigger a re-render because the reference is different. What does that mean? If we should set user to name an object where the name is Alex, and we set user again to an object where the name is still Alex, this is going to be seen as a new object. That is because even though the properties are similar, the reference is different. So because the reference is different, React is going to re-render. Why? Because React uses object.is to compare. So object.is, even if we pass in 2 empty objects, you can see React says this is false. So you can see even though the objects are empty, right? They look the same. It's still saying that it's false, right? So new objects always re-render. Okay. Number 5, same JSX is equals to same element, which means no re-render. Let's take the code on the left, for example. So as you can see, we have the parent component, right? In there, we have a state 0. Then we're returning a component that has another component called slow child. Then we return a button where if it's click, we update the state n by n plus 1. Okay, so when we click slow child, when we click on this component in the parent, this button component, which is inside the parent, slow child would also re-render. Why is that? Because the cascade triggers slow child on every click. Okay, so instead, let's take the example code on the right. So rather than having slow child inside the parent component, which will cause it to always re-render when the parent does, what we can do is, as you can see, the parent component is on its own over here, right? And then we have the app component, which then which then passes the slow child component as a child prop, as a children prop to the parent component. So the parent component receives the slow child component as a children prop where it is rendered here. So that means a click on the button in the parent component does not cause a re-render because slow child is not part of the parent component. Do you understand? It is just a prop. So I hope, I know this can be kind of a mouthful, but I hope you understand it. So let me just go through that again. The slow child component, it's outside the parent component. It is just being passed as a prop. So a re-render in the parent component does not cause the slow child component to re-render, unlike in this case on the left. Okay, so the mechanism. When JSX comes from above as prop, React sees the same element reference across renders. So what does that mean? It means same reference means no work. This is the cleanest memoization you can get, and it requires 0 hooks. Okay, number 6. Context re-renders every consumer. Context has no selector. Any consumer of the value re-renders on the value change. So don't just dump unrelated states into a context. Make sure to split context by what changes together. For example, you can put your theme in one, you can put your user information in another context, layout in another. So the theme change doesn't re-render everything, that just every consumer that just might be consuming only a user information. So split context by change frequency, not by feature area. For finer grained reads, use zotstand, jotai, or use sync external store. React.memo doesn't stop context re-renders. Okay, let's take a sample code example on the left. App context value changes. This is going to cause every use context, so every consumer of that context, to re-render whether they care or not. In this code example, we have a context, app context. Then in the app component, we have a state for the user and we have another state for the team. So if the team state changes, it's going to re-render user-only consumers. So if there are users that are only using, so if there are consumers that are only consuming the user data, they don't care about the team state, a change in the team would also cause them to re-render, which can be not productive. Okay, so this is where splitting context would help you. Number 7, external stores re-render their subscribers. So selectors are how you opt out of irrelevant store updates. Granular selectors are why zotstand and Redux can outperform context for shared states. Each subscribe component only re-renders when its slice changes. So this is going to be efficient because it doesn't re-render not when the whole store changes. So we're going to always select the smallest possible slice. For derived data, use the store's selector composition. Equality function matters here. So you have to compare shallow versus deep and by reference or by value. Okay, let's take a code example on the left. So zotstand, tanstack query, Redux, jotai all use sync external store under their hood. So component re-renders when the selected slice of the state changes. So let's pay attention, this selected slice when it changes. What does that mean? Let's take this value count, right? We want to know the count of something. So as you can see, we are passing useStore, and in useStore, we're going to get the store, which is the entire store, and then we're only going to select the count value from the store. Okay, so this is then going to cause a re-render only when the count changes, rather than in this scenario where we are selecting the count, but we're getting the whole store. So since we're not getting the slice, like here, whenever something changes in the store, right, it's going to cause the component to re-render. Okay, so this is why selectors matter. Number 8, read the React profiler properly. There's going to be a different video where we're going to cover the React profiler, and so be sure to subscribe to keep up with that. But let us look at 4 things that you can pay attention to. Number 1, what rendered. You can look at each bar, which is for one component, which is for the component render time. So if the bar is wider, this means that the render time is slower. So you want to hover over it to know why did this re-render. Okay. So number 2, you want to look at the ranked chart, which is going to show you what's slowest. So it's a sorted list of the slowest renders in the commit. Start optimizing here, not from the flame graph, which is what shows you what rendered. Number 3, why did this render? So you can click on any bar. The reason will be one of if the prop changed, the hooks changed, states changed, or the parent re-rendered. Okay, last but not least, commits and no renders. So each commit represents a batch. Filter to find the slow ones, Most renders take less than 1 milliseconds, and those ones are not the ones you want to pay attention to. So don't optimize what you have profiled. The profiler tells you what's actually slow. Most obvious performance fixes are placebos until measured. Okay, so now let's talk more about that. Number 9, most extra re-renders are fine. Let's take the code on the left. As you can see, this component rendered 5 times. This is a header component. It renders in about 0.2 milliseconds. It re-renders 5 times per second. So 5 times 0.2 would be 1 millisecond of work. So optimizing this just because of how low the render time is kind of pointless, right? So let's not waste time optimizing cheap renders. However, let us look at the code on the right. This is a component data grid, receives rows as a prop, and it renders in 80 milliseconds. It renders on parent change. So let's say it renders 10 times. So 10 times 80 milliseconds is going to be 800 milliseconds. This is a lot of time, and this is what memoizing. So this is why it's important to profile before you reach for memo. Okay. So a render under 1 milliseconds doesn't really matter, even at 60 frames per second. So we want to focus on the component in the profiler's ranked view. That's where the win live. Everything else is noise. Number 10, re-renders explained in one diagram. Let's talk about what causes the trigger, the render, and the commit. So number 1, set state, right? This is when we call the function, and then we do a differentiation of the old versus new to see what changed. Number 2, when the parents re-rendered, right? We build a new tree and we only update what changed. Number 3, context value changed. So we're going to run hooks and then we're going to change the necessary nodes, right? Number 4, hook subscription fired. This is pure, no DOM, and this is where we run the effect. So what are the bailout points? The bailout points are, as we've discussed, if the same primitives set state, right? So if we set states like integers, boolean, strings, there's going to be no render if the values are the same. Then number 2, react.memo plus the same props is going to result to no render. Number 3, same JSX from above, just like we saw in the example. There's going to be no work in the subtree, so that's going to cause a bailout. Number 4, the output is identical. So render happened, but commit didn't. Okay, so memorize these trigger columns. Every render question of why did this happen, come back to one of these 4. Then you can check the commits and check on why it's actually slow using the profiler. Okay, so this is a cheat sheet. You want to pause. It covers everything we've covered in the video. So just a brief cheat sheet for you. You can pause and look at it again. And of course, the best way to master a topic is by learning and practicing. So be sure to check out our courses in the description box below, and I'll see you in one of them. Thank you. Okay, thank you for watching, but here's the hard truth. Mastery doesn't come from just watching tutorials. They come from practice. That's why our courses focus on building real-world projects with the skills we learn here. So at the lowest price, you can enroll today and check them out. Thank you.